Hi, everyone. Before I jump into the actual lecture and do the regular introduction, this video is going to be just some announcements about where we're at in the class and what's going on. Uh, so, for one thing, your project one, the third part, is due this coming Monday. Uh, the blur filter on this project is tricky. It's not too tricky that you can't do it, but it is tricky enough that I wanted to put together a hint video to help get you unstuck if you're feeling stuck or overwhelmed by the size of the problem. I encourage you to use this hint video, similar to the video I did for the Caesar cipher, as a way to see and learn how to break down a larger problem into smaller pieces. So don't just think of it as me giving you something to start with. See if you can follow along with the reasoning that I use to structure my code or structure my solution or the way I approach the problem in the way that I did. So you can find it on the course website. If you go to CSCI100.org, on the calendar tab next to the project, there's a link here for the blur filter hints video. We've also just released homework 4, and it's due this coming Sunday, October 31st. This homework is a great way to practice for the exam. And speaking of the exam, by the way, you have your second exam coming up. It'll be November 1st in class, same format as before on Mimir, same exact situation where I'm kind of Mimir logs keystrokes, and we'll proctor it exactly the same way. You'll show up, you'll have your camera on, be on Zoom, and a TA will be watching. Same as last time, the TAs are there to answer your questions. And so what you should be doing is messaging the TA if you have any question in your Zoom breakout room. If you send a question and you don't get an answer, it's your responsibility to send the question again. Sometimes, especially at the beginning of the exam, there's a bunch of questions all at once. And if Vijay or I or one of the TAs miss your question in the chat, in the direct message, if you don't get a response within a minute or two, just send the question again. So this exam is going to focus on everything from the last topic that wasn't on exam 1, which was functions. So starting from September 20th, going all the way up through this lecture that we're looking at today, which is pass by reference and pass by value. So the material from the next lecture, which will be October 27th's lecture, will not be included on the exam. And so here's just a partial list of topics: functions, lists, mutability, input-output, dictionaries, 2D lists, nested loops. We're probably going to ask you to write some code to solve problems using these things. Now, this is as not cumulative as I can make it, meaning I won't particularly go and try to hammer some of the stuff that came before the last exam that was on the previous exam. Well, however, just by the nature of how this class is built and how computer science works, all of the previous topics are still fair game because you have to use variables to code, basically no matter what you do. You have to think about data types and operators and conditionals and string functions and loops. They come up all the time. And so even though this isn't really intended to be a cumulative exam, you will almost definitely see the topics that were from the first exam at least mentioned or used somehow in this exam. They just won't be the primary focus. And it's not what we'll have in mind as we're writing the exam. How should you prepare for this exam? So do homework 4. Homework 4 has lots of coding problems using exactly these things, using lists, using dictionaries, mutating given values, so writing a destructive function or writing a non-destructive function. That will be a great way for you to prepare. And if you're able to comfortably do homework 4, I expect you should be in a good place for the exam. We're also going to be releasing a practice exam, or at least a set of practice questions that are going to be similar to the actual exam, likely on Monday. And you can go through it, ask questions on Piazza or in office hours. But really, like, yeah, come and get help. Bring your questions, and we're here to answer them. A word about grades in this class. So your final grade is going to be made up of how you did on the exams with a decently large percent, and the projects, the homework, all this stuff. If you didn't do well on the first exam, it's not all over. You can still get a good grade in this class. Certainly, you can absolutely still pass, but you'll have to put in the work and the effort to prepare for this exam and come and get help. Don't wait until the night before to start studying. That's already too late for you to get help when you run into problems. Now, on the exam, there'll be questions that'll be like, there might be questions like something that says explain in a couple sentences. If we ask you to explain what a function does in a few sentences, that doesn't mean write the code in English words and sentences. So that doesn't mean like read out loud what this says. It means you want to summarize the function, kind of like a function comment. And so, for example, here, this is a good summary for this function. So it returns the absolute value of a given number, which is the positive value. You shouldn't say something along the lines of, if you're given a number greater than 0, return the number, otherwise return the number multiplied by -1. That's just like reading out loud what these lines of code say. That's almost the same thing as just saying, if num greater than 0, return num, otherwise return num times -1. So if we ask you to summarize what a function does, we're asking you to basically write a comment. Yes, and the last thing I think I want to mention here, the last couple things here are in testing. So you'll notice homework 4, the final project, probably homework 5. Now that we've taught you about testing, we're asking you to start writing tests for your code. The way you should think about writing tests is, how do I break my code? So what do I try that might make my code not work? And actually, in the real world, often we think about testing code where you can't assume that the user is good. Meaning, good could mean like malicious or not malicious. It could also just mean like smart or not smart. Like you could have someone who doesn't really understand what the input is supposed to be to a function, to your program, and you're asking for a number, and they give you something like, you ask for an integer, and they give a float for some reason. And so, really, like, professional grade code tests all these different inputs and doesn't make any assumptions about, hey, the user will follow this set of rules. In this class, I don't need you to worry about thinking, oh, well, if I write a function that takes in an integer, do I need to test if the user gives me a string, or all this stuff? The important thing is to find to make sure to test the like edge cases for the type that you're expecting. And so depending on the question, if you're working with something that takes a list, make sure to test what happens if there's an empty list. Or what happens if you give an empty 2D list? Like, well, does the code still work? If you take something that's like a string, like, for example, the introduction function that we've been using all the time, like introduce Vijay, that prints out, hi, this is Vijay. Does it still work if there's an empty string? What happens? So these kinds of edge cases, you should always make sure to test weird inputs. That'll be it for the announcements, and I'll see you now in the actual lecture videos.